Hi Trigoners, so this is 3.3. We're going to start with 6 basic functions. And so basically what we're going to do right now is that there are 6 functions that we are going to, I guess, memorize the graphs, what they look like, and some of their attributes and some things about them. And then what's going to happen is later on we're going to do something called transformations where we move them around. We might move them up or down or right or left or stretch or shrink or reflect. And we're going to be able to graph things without a calculator fairly quickly if we can start with the parent function. So the first parent function that we're going to start with is y equals x squared. Okay, so what we're going to do is we're going to pick a few points for x, and we're going to graph them we're going to graph these ordered pairs. So go ahead and think about what you might want to pick for x, which for choose for the independent variable. So I would probably choose like a -2, a -1, maybe a 0, a 1, and a 2. So go ahead and pause the video and fill in the table. Okay, so hopefully you were able to fill in the table. And let's go ahead and graph those points. And again, realize that we have arrows because these graphs continue. So what I would like you to do now is pause the video and write the domain and range of the quadratic equation. Okay, so we used interval notation. The domain is all real numbers because, again, these arrows continue in both directions. So an x value could be all real numbers. Now, for the y's, the smallest y value is 0, and that is included. So hopefully you said 0 to infinity. So what I would like you to do now is to think about the next function that we're going to do. This is called the absolute value function. So this was a quadratic, and this is an absolute value. So after we pick some values for x, I would like you to fill in the table and then sketch a graph and find the domain and range. So go ahead and pause the video and do all of that. Okay, so how did you do? So again, notice that there are x values from -infinity all the way to positive infinity, and the smallest y value is 0, and it is included. Okay, so let's go ahead and think about the next two. This is actually the square root, or you could say a radical x or square root function, and then we have a cubic. Okay, so now when I pick values for x for the square root function, I'm going to be careful because first of all, we don't get a real number if you take a square root of a negative number. So I would choose 0, and then I'm going to make it easy on myself. I'm going to pick perfect squares like 1, I might pick 4, 9. I certainly wouldn't pick something like, well, I guess you could pick 5 or something like that, but again, that doesn't sound like it'd be very easy to do. And then over here, I think I would pick the -2, -1. But again, you can pick anything you want. I'm going to have you pause the video and fill in the table, sketch the graph, and write the domain and range. Okay, so for the square root function, that's number 3. Notice that 0 is the smallest value of x. And notice, but you could pick values up through infinity, and notice that the y value, the smallest y value, is 0. So because again, radical and then a negative number, that is not real. That is not a real number. So we are only using non-negative numbers, non-negative real numbers. So let's take a look. Oh, I didn't fill this in. So if you cube -2, negative to the third power is a -8. Okay, so let's go ahead and do the last two. Whoops. There we go. So we're going to use y equals 2 to the x. This is an exponential function. And y equals x, which hopefully will be very easy. So why don't you go ahead and fill in the table. Again, you could pick any values for x that you want. I just think it might be easier if we all pick the same ones. And fill in the table, plot your points, and then write the domain and range. Go ahead and pause the video. Okay, let's see how you did. So I actually did number 6 first because that one was really easy. The exponential, some of us might have a little trouble with that. So let's go ahead and do that together. So if I say the y value is 2 and then I put negative 2 in for x, notice a negative exponent says, move me, I'm in the wrong place. It says put that in the denominator. So now the exponent's positive. So that's why you get a 1/4. And then if you have negative 1, again, that's a negative exponent, so now it's a positive exponent if you move in the denominator, so that would be 1/2. 2 to the 0. Anything to the 0 power by definition is 1. Well, I shouldn't say that. A real number other than 0 to the 0 power is 1. Because again, if you have 0 to the 0 power, that's undefined. Okay, so we have 2 to the 0 power, that is 1. And now 2 to the first power is 2, and 2 squared is 4. Okay, so let's go ahead and plot those points. Negative 2, 1/4, negative 1, 1/2. So notice what would have happened if you would have picked something smaller. Like, for example, if we would have chosen like a negative 10 for x. If I want to know what y is, 2 to the negative 10, well, that's a very small number. So notice what's happening is there's a horizontal asymptote here at y equals 0, and your graph is approaching 0. And as x gets larger, y gets larger. So now if I wanted the domain and range, the domain is all real numbers, but the range is from 0 to infinity, but not including 0, because again, there's a horizontal asymptote. It does not, the y value does not equal 0. So there are your 6 basic functions. So we are going to remember what they look like, what their domains and ranges are, some special characteristics of the 6 basic functions. Nice job, everybody.